In this lesson, we are going to introduce the idea of now the reciprocal functions for our trig ratios. So before we do that, to introduce, we're going to use this ABC triangle here and sine of theta. So this is our reference angle here. Sine again, right, is opposite over hypotenuse. So opposite is 3. That means the hypotenuse is 5. So if we wanted to know what is cosine and tangent, well, first you got to figure out this missing side, which what do? Pythagorean theorem. So go ahead and pause the video, get the missing side here, and find cosine and tangent. So notice how here you should have gotten 4, right? So 3 squared plus x squared is equal to 5 squared. Solving, you get 4. So the cosine of theta, so sine was 3/5. Cosine of theta is adjacent, so 4/5. And tangent of theta is opposite over adjacent, which is 3/4. Now, notice here, secant, this is something new that we're going to focus on. This is one of our reciprocal, is 5/4. Then we've got cosecant, which is 5/3. And then we've got cotangent, which is 4/3. So how do you think that secant, cosecant, and cotangent are related to the original? Well, if you noticed, secant in relation to cosine, except it was flipped, right? Cosine was 4/5, secant was 5/4. Cosecant, well, sine, but flipped. So notice how sine was 3/5 and cosecant was 5/3, 5/3. And cotangent is tangent flipped, the reciprocal. So tangent was 3/4, cotangent was 4/3. And that is our reciprocal relationships. Sine and cosecant are reciprocal functions, sine and cosecant. So if sine was opposite over hypotenuse, cosecant is hypotenuse over the opposite. So we're taking sine and flipping it. So then cosine and secant are the reciprocal. So here adjacent hypotenuse is cosine, so secant is hypotenuse over adjacent. And last is tangent. Tangent and cotangent are reciprocal. So tangent and cotangent. So here, if tangent was opposite over adjacent, cotangent is adjacent over the opposite. So again, we've got this reciprocal relationship. So we'll need to first identify what the original is, then understand how we write it to get the reciprocal. So again, we're focusing still on SOHCAHTOA, but then make sure to identify and flip. So like here, if I want to know cosine of theta, well, cosine is the adjacent over the hypotenuse, right? So adjacent is 5 with your hypotenuse of 13. Now, secant. Well, secant is the reciprocal, if you need to go back, secant is the reciprocal of cosine. So if secant is in relation to cosine, that means we don't want adjacent over hypotenuse now, right? We want hypotenuse over adjacent. So we want to flip. So that's why here it's 13/5. Then cotangent. Well, cotangent is the reciprocal of tangent. So if tangent was opposite over adjacent, then cotangent is adjacent over opposite. So the adjacent here is 5 over opposite, which is 12. So notice that reciprocal. So now here, before we continue, we need the hypotenuse. So again, Pythagorean theorem, 4 squared plus radical 2 squared is equal to x squared here. So we've got 16 plus, now notice radical 2 raised to the second power, they're inverses, they're opposites, so they just cancel out, and you're left with 2. So now I've got 18 is equal to x squared, take the square root. However, can we simplify radical 18? Yes, because radical 18 is 9 and 2. What is the square root of 9? 3. So 3 radical 2 is the hypotenuse. So tangent of theta. So tangent of theta is opposite, which is 4 over adjacent, which is radical 2. However, can we leave this as is? No, because of the radical. So we need to rationalize. Radical 2 over radical 2. So this is 4 radical 2 over 2. Now, can we simplify? Yes, because 4 divided by 2 is 2. So tangent of theta is 2 radical 2. So now cosecant. So again, cosecant is a reciprocal of sine. So cosecant and sine. So sine is opposite over hypotenuse, which is 4 over 3 radical 2. So we already know here then sine is 4 over 3 radical 2. We'll get to that. Then flip, so this is 3 radical 2 over 4. Now can we simplify? No. So this is cosecant. However, for sine, can we leave it? No, because of the radical. So we're going to multiply by radical 2. So here I've got 4 radical 2 over, now radical 2 times radical 2, that just cancels out, right? And you're left with 3 times 2, which is 6. So this is 4 radical 2 over 6. Now, can we simplify? Yes, because that is 2/3. So 2 radical 2 over 3 is sine. So go ahead and pause the video and try the U-try on your own. And here we go. So here, to get the hypotenuse, you should have used Pythagorean theorem, which is radical 500. However, simplify, because this is 100 times 5. So here you should have gotten 10 radical 5. So cotangent. Well, cotangent is the reciprocal of tangent. So here we need adjacent over opposite. Flip it. So adjacent is 10 over 20, which is simplified to 1/2. Now, cosine, well, cosine is just adjacent over hypotenuse. So adjacent is 10 over 10 radical 5. However, we cannot leave this as is, right? So we need to simplify. Now, you could have simplified, so let's just say some of you simplified first. So this is 1 over radical 5 because the 10s just cancel out. Now you can keep going. So this is radical 5 over radical 5 to rationalize. So that's how you get cosine is radical 5 over 5, because again, rationalizing, canceling out. So cosecant, if you needed to look back, cosecant is the reciprocal of sine. So if sine is opposite over hypotenuse, you needed hypotenuse over opposite. So the hypotenuse is 10 radical 5 over the opposite of 20, which can be simplified to 1/2. So this is radical 5 over 2, because it's understood to have that 1 here. So now here, if you need to, redraw. So here I've got my lengths here of hypotenuse is 17. The opposite from your theta is 8, and the adjacent is 15. So if you need to, use this to identify. So here I've got sine. Well, sine is opposite, right? So SOHCAHTOA. So sine is opposite over hypotenuse. So hypotenuse again is 17, so 8 over 17. Cosine is adjacent, which is 15 over 17. And tangent is opposite over hypotenuse, or adjacent, sorry. So 8 over 15. So again, just practicing, right? Cosecant. So cosecant is the reciprocal of sine. So 17 over 8. Secant, 17 over 15, reciprocal of cosine. And cotangent is the reciprocal of tangent, so 15 over 8. So again, if you need to, redraw. So we know that cosine is adjacent over hypotenuse. So the hypotenuse is 5, and then from theta, the adjacent is 2. So to identify here, you got to use Pythagorean theorem. So x squared plus 2 squared is equal to 5 squared. So here we've got x squared plus 4 is equal to 25. Subtract 4. Now we're at x squared is equal to 21, square root. Now can we simplify? No. So radical 21. So sine is opposite and hypotenuse. So radical 21 over 5. Tangent is opposite over adjacent. So radical 21 over the adjacent of 2. So now getting into the reciprocal. Cosecant is a reciprocal of sine. So 5 over radical 21. But can we leave it? No. So radical 21 and radical 21, which leaves you with 5 radical 21 over 21. So then secant is the reciprocal of cosine. So secant is 5 over 2. Then cotangent is the reciprocal of tangent. So 2 over radical 21. But again, make sure to rationalize radical 21. So you've got 2 radical 21 over 21. So just again to make sure that you identify here, right? So cosecant is the reciprocal of sine. So all we've got to do is flip. So cosecant is 5 over 4. Now, this is a little different because we need to find cotangent based on given secant. So again, here we can redraw. Secant is the reciprocal of cosine. So again, keep in mind that this is then hypotenuse and adjacent. So here, the hypotenuse is radical 13. The adjacent to theta is 2. So here we need to get the opposite. So using Pythagorean theorem. So here we've got x squared plus 2 squared is equal to radical 13 squared. So x squared plus 4 is equal to, canceling out, you're just left with 13. So now here, subtract 4, and you get x squared is equal to 9. Take the square root, and here you got 3. So now cotangent is the reciprocal of tangent. So if tangent is opposite over adjacent, which is 3 over 2, then cotangent is 2 over 3. And so now here, go ahead and pause the video and try the U-try on your own. Now, this is a typo, sorry about that, and we'll fix this also in class. This should have been 12 over 9. And here we go. So again, if you Get that visual, right? Recreate. So here's theta. Now, cotangent is the reciprocal of tangent. So tangent is opposite over adjacent. This is adjacent over the opposite. So adjacent is 12 and the opposite is 9. So again, here to get the hypotenuse, Pythagorean theorem. 9 squared plus 12 squared is equal to x squared. So when you solved, you should have gotten 15. So now here we can see that sine is just good old opposite over the hypotenuse. So this is 9 over 15. Then of course you can simplify this to 3 over 5.